Good morning, everybody. Get started. My name is Jay Hannon. I work with IBM, and I'm session chair for this morning. I'd like to welcome you to this session, and I have a couple of housekeeping notes, if I can, for you, just to observe. First is one, turn off mobile phones. Second is about the dinner this evening. Please. For those who are attending the conference dinner tonight, and I hope that's most of you, there'll be buses departing at 6 p.m. from Ridge's World Square Hotel, Pitt Street. So that's about one block away from here on Pitt Street. That's Ridge. And that will transport you over to Dalton House, where the dinner is tonight. So please be there 5 minutes early. In other words, be there at 5 minutes to 6 this evening. The second is that the Australian e-Research Forum is on today. It's at 10:15 today. If you have any questions for them, email them through as soon as this session's over. I've got the email address here if you need it. But make sure you get them in, otherwise it's 10:15, the questions as you get them soon. So with the housekeeping done, I'd like to just introduce our next speaker. Our next speaker is from IBM Research Labs in Melbourne, the new IBM Research Lab is located there. Dileban Karunamoorthy is a fellow that started in industry. He then moved about 3 or 4 years ago to the University of Melbourne and became a research fellow at the Clouds Lab at the university. He joined IBM this year. Specifically with the purpose of managing IBM's research infrastructure, and particularly our cloud infrastructure. And in addition to managing that, he has an ongoing responsibility to conduct research into platforms in cloud. So, not surprisingly, he is very closely connected to the long-standing IBM Research Cloud. And so I would like to introduce Dileban, and he's going to talk today on that research cloud. So Dileban, over to you.
Thanks, Jay. So this talk is about IBM's Research Computing Cloud. It's a lot less about cloud computing itself, but more about the whys and whats of RC2. So before we begin, I'd just like to give a quick introduction to our lab. Our research lab was set up in mid-2011. It was the 11th lab to be set up by IBM, the 12th being the most recent, and that's the one in Kenya in Africa. The lab is headed by Glenn Whitewick, and I believe some of you met him yesterday. It's located in Carlton, just off Melbourne CBD. We have a staff of about 40 people at the moment. Some of them are interns, and there's a plan to, actually the current plan is to increase the staff count to about 150 by mid 2016. So the focus of the lab is largely going to be on customer-driven problems in the areas of disaster management, natural resource management, healthcare, government, and finance. And we also hope to build and continue to build strong relationships with many of the universities in Victoria. And if you need to know more about university relations, I think the best person to talk is Jay here. The lab in Melbourne also has access to a large pool of researchers in other research labs across the world. So the Research Compute Cloud is basically an infrastructure service offering for the research staff within IBM. And the Research Cloud spans multiple research labs across different geographies. The strategy behind the research lab is twofold. One is to cut down IT expenditure in research across IBM Research, and the other is to support innovation and research in cloud computing itself. And I'll come back to that in a second. So there is a lot of activity going on in cloud computing across the different divisions in IBM. And one of the key things that IBM Research is doing is actually forming close partnerships with the other divisions in IBM. And these include the software group, the systems and technology group, and global technology services. So cloud is all about scale, right? I mean, you need to have access to a large environment if you really want to test your various algorithms and your technologies that you're developing. So the purpose of creating, one of the main reasons for creating this research lab, the research cloud rather, is to provide cloud researchers an environment where they could actually do research in cloud computing at the scale of cloud computing itself. So IBM is setting up a global cloud federation across the different research labs. We started off with Australia, Watson in New York, and Haifa in Israel. China and India will be joining us early next year. And eventually, most other labs are going to be joining and becoming part of this federation. The development process in place will ensure that there is always minimal disruption to the researchers, the consumers of the cloud service. So, traditionally, you would typically have a deployment process where you'd have a testing environment, a pre-production environment, and you'd have a production environment, and you push code in increments to the different environments so that users can get a feel of what new features look like. You would start by deploying some of the new features in certain data centers, not all data centers at the same time. So by following certain good practices in software development, you can ensure that you could actually do development on the cloud itself simultaneously while people are actually using it. This strategy also helps to build confidence amongst IBM's clients or potential clients by demonstrating that IBM has confidence to use its own cloud infrastructure for strategic projects within IBM. And it's not just something that's built and sold to customers and not using the software themselves. So the other motivation for the research cloud is to provide IT service to the researchers. And traditionally, researchers went through weeks in order to get access to an environment, and going through various stages from hardware procurement to getting hold of software licenses, installing, configuration, and doing all that stuff. But with the research cloud, researchers can now launch entire environments within minutes, and they could start doing the research work and spend less time fiddling with the kind of work that sysadmins typically do. And the reduction in lead time, as well as the chargeback model in place, ensures that researchers are more than happy to give back resources when they're done, and not hog resources for long periods of time, which is traditionally been the case when researchers found it hard to get access to environments or hardware. They usually don't give them up even after they finish their research work, because they know that it's a lot hard to get them back again. So researchers can also create their own images, configure it the way they want. They could share it with other researchers across the globe. And the RC2 platform also works across different hardware systems, so whether it's x86 or power systems. And here, this graph, what I wanted to show is that the usage in RC2 has been increasing over the past couple of years within IBM Research. And the graph basically shows the accumulated VM hours for various months during the past 2 years. And the key thing here is that the research cloud service is not a service to make profit. It's a not-for-profit service. So which means that the idea is to become cost neutral, to be able to recover as much cost as possible, so that they could manage the investments in capital and also manage the labor costs, but not to actually make a profit. Any increased profits lead to a reduction in prices to the researchers. And the good thing is that by cutting down on IT expenditure, IBM can focus all that expenses on research work, which is more useful. So here is this is just a run through of some of the features, which is typical of most cloud platforms that you would find. There is a common Web 2.0 portal. And again here, as I mentioned earlier, we plan to work closely with some of the IBM divisions. So this portal that you see here is actually going to be replaced with a portal that is going to come from the software group, which is a lot nicer. There is from IBM researchers' point of view, there is no real value in spending a lot of time building a commercial grade portal. There is a monitoring service where you could use to monitor your resources. There is a billing system in place so that users can look at what costs they incurred. The prices are very similar to Amazon's prices. Researchers themselves don't really pay for this. It's the department that pays for this. The platform also supports different operating systems, including IBM's AIX system, Linux, and Windows. There's also a good license management system in place that ensures that users can track, or the system can track, how many hours are spent in relation to each of the different licenses that are being used. There are dashboards to show various statistics about how different services in the cloud is being used. There's an image search feature where researchers can find images they'd like to use, images relating to maybe optimization, to Hadoop environments, whatever there is that you can find. The provisioning system in RC2 is extremely fast. You can provision hundreds of VMs within a matter of minutes. There is a REST API, as you would find in most cloud services. There's also block storage for reliable storage if you want long-term storage. If you want to preserve your storage even after a VM is terminated, there's block storage in place. And of course, this is just keep authentication for Linux instances. So this is a very high-level architecture of RC2. I left out a lot of the details, and I think a discussion on architecture would probably take more than 15 minutes. So basically, I just want to show that there's two parts to it. There is a front end, which is the main portal and various other components that go with it, like the monitoring component, reporting, and chargeback. And there's a backend component called Smart Cloud Provisioning. One of the key components of Smart Cloud Provisioning is HSLT, which stands for High Scale Low Touch. It's a component that is able to provision a large number of VMs very quickly. There are a bunch of bots that run in each rack. These bots, some of these bots play a managerial role, whereas others generally receive tasks from the managers for provisioning. So, for instance, you would find a hyperbot, which is a manager bot, that would receive a provisioning request from the HSLT component, and you would forward it to the different racks. There's an image library in place to keep track of all the images that researchers need. The HBase cluster keeps track of the state information used by the various services, and the Zookeeper is used for configuration and synchronization and things like that. So, for instance, if one of the manager bots were to die, Zookeeper would be used to elect a new manager. Yeah, so I'll just skip that. So the obvious benefits to IBM research is that it brings about agility and innovation. Cloud researchers have a platform that is of cloud scale. They could actually get into it. They could do a lot of interesting code, write interesting algorithms. You could test interesting stuff there. It brings about better asset utilization, reduced lead time for researchers to getting hold of systems. There is centralized management, and which makes it easier to enforce security compliance and patching, which is very important to many organizations, and monitoring and accountability. It also encourages greater collaboration across researchers across different research labs, and also reduction in overall expenditure, both capital expenditure and operational costs. So going forward, some of the new features that we'll see in the next 2 or 3 quarters in the Research Cloud is object storage. Object storage is similar to Amazon's S3 and OpenStack Swift. It lets you store a lot of unstructured data, such as documents, videos, audios, and it's very useful for a lot of big data problems. Automated patching and security compliance will ensure that all your VMs in the system are security compliant. If you're an organization, I think this is very important because you don't want your auditors coming and complaining that you have VMs that are exposed to the internet and they're not really compliant, and you don't really want to spend a lot of time managing this manually. Workload-centric clouds is a very interesting project that is going on in research. It's about being able to compose entire software environments using a high-level modeling language, where you could also set certain quality of service requirements like performance, high availability, redundancy, and there's a runtime and an orchestration engine in place that will take care of deploying this whole system and constantly monitoring and making sure that the quality of service is maintained. The catalog of virtual system patterns helps researchers to create patterns for common environments like an optimization environment, Hadoop cluster, and they could share these patterns to other researchers. Deploying a pattern is just a matter of a few clicks, and these can help reduce time. So security zones, again, is similar to what Amazon offers. These are basically firewall environments. It basically shields your VMs from other VMs in the same subnet or the same rack. This is important when you're working with sensitive data from customers. There's also a federated workload management system in place that's coming along. And what this will do is it will basically help you deploy systems that can span multiple data centers. And this will be managed seamlessly. So supposing you are in Australia and you're doing an experiment and you don't really have enough resources, the system will take care of bursting out into other data centers and acquiring those resources for you. And RC2 Analytics Cloud is a new cloud that is coming along that is optimized for big data problems, for analysis. So basically, apart from optimization at the infrastructure level, this also includes a number of tools and software for analytics and business intelligence. And in closing, I'd just like to say that there's a lot of questions being asked around why RC2 and why not OpenStack. But I just wanted to point out that the RC2 project began in 2007, and IBM wants to be a key player in the cloud market, so they also want to explore ways of bringing new features into clouds and innovating in different ways. Whereas OpenStack came about in mid-2010. But IBM recognizes the important role that OpenStack can play across different organizations, and is also interested in contributing code to the OpenStack Foundation. So IBM is a platinum member in the OpenStack Foundation. Some of the key contributions that IBM intends to make is HSLT, which is the component that I spoke about, which is provisioning large number of VMs very quickly. And IBM is also building its own distribution of OpenStack. So in conclusion, RC2 is a constantly evolving platform. It is the main research platform for IBM. It's a platform for innovation in cloud computing. It's a strategy for reducing CapEx and OpEx across research so that research can focus on more transformational projects. And IBM is also making RC2 available to other research organizations. Thank you.
Thank you, Dileban. Very, very interesting. We have time for a few questions, several questions. If anyone has a question, hand up, please, and do can use the microphone as a candle. Go ahead, please.
I came late to the presentation. You probably might answer. You probably covered this area. So my question is the RC2 available for public? Like if you are for Amazon, you can use for a year a kind of free subscription, so you can play with it. So is there the same kind of thing for RC2?
Yeah, so as I mentioned, RC2 is mainly a platform to be used within IBM Research.
Okay.
It's been made available to other organizations, but that will involve transferring IPs and all that stuff. It's not an open source project.
Okay.
But if you want to use IBM's cloud services, there is something called IBM Smart Cloud Enterprise, which is a public cloud offering similar to Amazon.
Okay.
But I do have to mention that is generally targeted towards large enterprises and governments. So you'd find the costs a little different, but you would also find there is a lot of support and additional features that come along which enterprise customers want. Okay. A lot of what comes into Smart Cloud Enterprise also comes from IBM Research. So okay. We basically use RC2 as a development platform to create interesting new features, and when we think that this is really good, we push that into the commercial version of Smart Cloud.
Thank you.
Any other questions?
You mentioned automatic patching as a feature.
Yeah.
Is the patching done through the operating system, through either direct login or a tool like Puppet, or is it done by manipulation of the disk image?
It's done by manipulation of the disk image.
Right.
Yeah.
So it can really scale out and handle a lot of virtuals and take care of all of that for you.
Yeah. And when users create new images, they're not really creating a complete new image, they're actually storing the diff.
Yes.
So you don't really need to patch too many images, you just need to patch the base image. And when you provision a new instance, so to give you an example, supposing a user launched an instance from a base image, like say Red Hat, and they installed some software on it, and they took a snapshot of that image. So when you want to patch that image, you only need to patch the base image, because the moment you launch an instance from the snapshot, it's going to take the base image, add all the diffs, and then launch an instance from that. So it's very scalable.
So you deal with any possible problems of underlying patching, breaking the application sitting on top of it.
Yeah, that's a good question. I agree. That's always going to be a problem. But if you think about it, a lot of operating system updates tend to be quite compatible.
Yes.
And they generally don't break APIs. They're always compatible with. So generally, I find that it's usually a lot of software that's badly written, that's using undocumented APIs that tend to break. But as long as you use proper APIs.
But you simply give people a mechanism to jump back quickly, and then you can investigate what went wrong.
Yeah, and also
the virtual being broken at the time.
And also the system in place ensures that this is not forced upon directly. So researchers get an email notification saying we need to apply these critical patches by this date, and there are certain optional patches which you can apply. So when researchers don't take action by a certain date, then the automated patching goes through.
One more quick question.
Yeah. Well, hopefully quick. About the federated management.
Yeah.
Can you talk a little more about how is the data transferred and how is the data made available across the federated sites?
I actually don't have a lot of details on that. But what I can say right now is that the cloud bursting feature is something that's going to come in the next quarter, I think, or the next 2 quarters. And I don't know, because I'm not in the development team, I actually don't know what the design is and how they're going to handle this. But if you're interested, I could always find out more about this, and I could probably pass it on to you.
Dileban will be around at the conference for a while this afternoon. So thank you very, very much, everybody, and thank you, Dileban.
Thanks.